Hey Year 11s, this is lesson 4 in our Biomechanics Flipped Classroom series of lessons. Today's biomechanical principle we're going to have a look at is Newton's laws of motion. The guy that's there on the right hand side, his name was Sir Isaac Newton. He lived in the 17th and 18th centuries, and he is the one who came up with these 3 laws that we're going to have a look at today. So let's do that. Let's look at the first law of motion, which is the law of inertia. And as you can see there, I've got a definition for you. So the law of inertia basically states that an object will stay in its original state until acted on by an external force. So an object that is moving will keep moving, or an object that is still will remain still until it's acted on by an external force. Some examples of external forces for you down there are gravity. You've also got the wall, air resistance, a club like a golf club, a body part, a foot or a hand or a leg, a bat like a cricket bat, or a racket, maybe a tennis racket for example. So that's the basics of the law of inertia. So let's apply that now and let's have a look at what I mean by this. So here we have a golf ball in the top right hand corner. Now a golf ball, that golf ball is just sitting there, and until a club acts on it or hits it, it will stay there. So it will stay in its original state of motion, which is still, okay, until a club hits it, and then hopefully it goes in the hole. Here down the bottom we have a basketball. Now obviously you can't see it because it looks like it's still, but this basketball is actually rolling across the gym floor. It will keep rolling across the gym floor until it comes into contact with a wall, and that will then stop its motion. And here on the right hand side we have a tennis ball that is flying in the air. Now it would continue to fly in the air, but we have gravity which is acting down on it, which will bring the tennis ball back to the ground eventually. So that's 3 examples. One is a golf club that will act on this golf ball to get it to move, to change its state. The basketball, we have the wall which will stop it, and in the tennis ball we have gravity which will bring it back down to earth. So those are 3 examples of the first law, the law of inertia. So let's have a look at the second law, which is the law of acceleration. Once again, you got the definition there for you. So the law of acceleration basically states that the greater the mass of an object that is being accelerated, the greater the force that is needed to accelerate the object. And they actually figure this one out by mathematical equation that is force equals mass times acceleration. So the force that's required is dependent on the mass that's needing to move or needing to be accelerated, and the acceleration that is applied. Okay, so that is the law of acceleration. The greater the mass, the greater the force that's needed. So let's have a look at some examples of this. Law of acceleration, second law. Here we have a shot putter on the left. Okay, and the shot put, as you can see quite simply, and we all know, is quite heavy. So we've got a shot put there. And the guy on the right, he is just throwing, you can't see it that clearly, but he is throwing a tennis ball. So if you're comparing the amount of force that's needed to throw a shot put in comparison to the amount of force that's needed to throw a tennis ball, if we want them to go the same distance, so if we want the shot put to go 10 meters and we want the tennis ball to go 10 meters, we will have to apply a lot more force to the shot put than we would to the tennis ball. Okay, so same example with the car you've got there. If you compare on the left hand side the guy that is pushing the car in comparison to the guy here that's pushing an empty trolley, obviously you can work out that you would need a lot more force to push the car than you would the trolley. And if you wanted them to go the same distance, then obviously more force would need to be applied to the car than to the trolley. So that's the second law, the law of acceleration, which is all dependent on the force that is needed in order to move that mass at the same acceleration. So the last law we'll look at, the third law, which is the law of action and reaction. for every action, there is an equal and opposite reaction. Okay, and to break it down and make it a little bit simpler for you, just here I've got, for every force, there is a reaction force that is equal in size but opposite in direction. So whenever an object pushes another object, it gets pushed back in the opposite direction equally hard. Okay, so let's have a look at what that means. So law of action and reaction. For every action there is an equal and opposite reaction. So here we have a rocket. So a rocket's action is to push down. So the rocket, its action is to push down on the ground. Okay, with its engines and the powerful force that the engine creates. Now the reaction, so that's the action, is that it pushes down. Now the reaction actually comes from the ground. And the ground pushes the rocket upwards with the equal force. And that then allows the rocket to take off into the sky. So the action is the rocket pushing down with its powerful engines, and the reaction, so the reaction, this is the action, the reaction is that the ground pushes the rocket up into the air. If we have a look at the guy down the bottom here, his action is to push on the wall. Okay, his action is to push on the wall, and the wall's reaction is to just push back with the same force. If he was pushing with more force than the wall would then fall down. But it doesn't, so we know that his action is to push on the wall, the reaction, the same amount of force as the wall pushing back against him. And lastly, the basketball example, if we're dribbling a basketball, the basketball collides with the floor, so here it's colliding with the floor, and then the floor's reaction, so the action is that the basketball is colliding with the floor, and the floor's reaction is to propel the ball back up into the air. And this process continues as the person continues to dribble the basketball down the court. So that's just a quick overview of the three laws, Newton's three laws. The first one being the law of inertia, that a body or an object will stay in its original state of motion, or whether it's still, until acted on by an external force. The second law, the law of acceleration, which is the greater the mass of an object that's being accelerated, the greater the force that's needed to actually accelerate that object. And the third law, the law of action and reaction, is that for every action there is an equal and opposite reaction. So I hope that you understand a little bit about Newton's laws, so that we can apply them in the lesson on Thursday.